this video, we're going to look at DeMoivre's theorem. So DeMoivre's theorem is stated here at the top of the screen, and it tells us something about a complex number in the form cos theta plus I sine theta. Specifically, it tells us that cos theta plus I sine theta to the power n is equal to cos n theta plus I sine n theta. So this is very handy for rearranging and solving equations. So it just tells us that whenever we have a complex number in this polar form, cos theta plus I sine theta, and we raise it to the power n, we simply times the theta in both the cos and the sine by n, and then we can get rid of n as a power. So we're not going to prove this in this video, we'll just take it as a given. We'll see how we can use it to solve a problem. So the problem is, write cos 3 theta in terms of cos theta. So that's what we're tasked to do. How can we do that? Well, some people might say, I've seen people do this before, where they say that the solution is cos 3 theta just equals cos cubed theta. Because if I look at DeMoivre's theorem, it tells me that when I have something like this, cos theta, and I raise it to the power n, in this case n is 3, it's just equal to cos 3 theta. So I can write this down. However, this is not true, because this is not what DeMoivre's theorem tells us. DeMoivre's theorem only tells us something about cos theta plus I sine theta. You have to have the whole thing. If you just have a cos theta, then this is not true that cos theta to the power n is equal to cos n theta, not by itself. So this is wrong, and the problem's actually a little more complicated. So what we can say is that cos 3 theta plus I sine 3 theta is equal to cos theta plus I sine theta cubed. So this is using DeMoivre's theorem. This is definitely true. We've just put n equal to 3 in DeMoivre's theorem. And this looks quite complicated and not that helpful because there's a lot of terms we don't need. We just want this cos 3 theta by itself, and we only want it in terms of cos theta. We have I sine 3 thetas and all sorts going on here. So we'll try and rearrange and simplify as best we can, and hopefully we get sensible answer. So we start by getting rid of this bracket on the right hand side. So this bracket is equal to cos theta plus I sine theta times cos theta plus I sine theta times cos theta plus I sine theta. So I've just gotten rid of the cubed, written it as the bracket out 3 times. And I want to get rid of this, so I want to times all these brackets together. So the easiest way to do that is to take the first 2 initially, times these together, and then we'll times the answer by the third bracket. So what happens when we times these 2 brackets together? Well, we get cos theta times cos theta. That gives us cos squared theta. And then we have cos theta times I sine theta. But we have 2 of those because we also have the I sine theta times the cos theta. So that's 2 I sine theta cos theta. And finally, we have I sine theta times I sine theta, which is I squared sine squared theta, but I squared is minus 1. So this gives us minus sine squared theta. And we need to times this by the bracket on the end. So to do this, the easiest way, because there's only 2 terms in the second bracket, let's times each of them through the first bracket. So we'll times everything in the first bracket by cos theta, and times everything by I sine theta. So first we get cos theta times cos squared theta. This gives us cos cubed theta. Then we get the cos theta times 2i sine theta cos theta. So this is 2i sine theta cos squared theta. Then we get the cos theta times the minus sine squared theta. That's minus sine squared theta cos theta. Now we'll do the same thing with the plus I sine theta in the second bracket. So we get plus I sine theta times cos squared theta. That's plus I sine theta cos squared theta. Then this is possibly the one you have to think the most about. We have I sine theta times 2i sine theta cos theta. The sine thetas will times together to give us sine squared theta cos theta, but then the 2i will times by the I squared is minus 1, so we get minus 2 sine squared theta cos theta. And then finally we have the minus sine squared theta times the I sine theta. That gives us minus I sine cubed theta. So now let's gather together all the real terms and all the imaginary terms. So if we want to put this in kind of standard form for a complex number, we should have a real part plus an imaginary part. So let's put all the terms with an I in them together. But we'll first gather together all the terms without an I, all the real terms. So what do we have that's real? Well, the first term, there's no I, cos cubed theta. So we'll put that down. And then the only other two terms that don't have an I are these two here. Sine squared theta cos theta, minus sine squared theta cos theta, and minus 2 sine squared theta cos theta. These are actually the exact same terms. They're each a sine squared theta cos theta. We have minus 1 sine squared theta cos theta, minus 2 sine squared theta cos theta. So in total, that's minus 3 sine squared theta cos theta. So we've combined these, and already therefore we've simplified the answer a little bit. So now let's focus on the imaginary part. So we have these two terms. First of all, 2i sine theta cos squared theta plus I sine theta cos squared theta. Again, we can combine these because they're the same, and we get plus 3i cos squared theta sine theta. And then the only other imaginary part is this bit at the end, I sine cubed theta. So we subtract it and we get minus I sine cubed theta at the end. So we had 6 terms, we've now only got 4 terms. So we've simplified things just a little bit. Now I'm going to go into a new page. I'll just put at the top here what we just stated. So we had that cos 3 theta plus I sine 3 theta, that's what we started with, equaled eventually cos cubed theta minus 3 sine squared theta cos theta plus 3i cos squared theta sine theta minus I sine cubed theta. So that's where we'd gotten to. You can rewind the video and look at the working if you want reminded of how we got there, but that's where we got to. What can we do now? Well, we can equate real parts and imaginary parts. So the thing on the left has a real part and an imaginary part, and so does the thing on the right. And if they're equal, that means the real part must equal the real part and the imaginary part must equal the imaginary part. But we can ignore the imaginary part because we don't care about that because we're concerned with cos 3 theta. Now that exists on the left in the real part. So let's just equate the two real parts and say that if the first line is true that those two things are equal, it means that cos 3 theta equals cos cubed theta minus 3 sine squared theta cos theta. So I'm just equating the real part of the thing on the left to the real part of the thing on the right. Now this looks almost what we want. We have cos 3 theta in terms of cos thetas, but unfortunately we also have a sine theta in there, and we don't want that. We're told to only express it in terms of cos theta. So what do? Well, we say that cos 3 theta equals the cos cubed theta, and then we just have to worry about this term with the sine in. But remember, sine squared theta plus cos squared theta equals 1. So that means that sine squared theta equals 1 minus cos squared theta. So we put that in, we get minus 3 cos theta. So I've put the cos theta in this term at the front, and then I've changed the sine squared theta that would be on the end to a 1 minus cos squared theta. Now we just need to get rid of this bracket to see what we have. So we have cos 3 theta equals cos cubed theta, I'll not change that, and then I times the minus 3 cos theta through the bracket to get minus 3 cos theta when I times it by the 1, and then plus 3 cos cubed theta. So the minuses cancel out. We get plus 3 cos cubed theta. Now I just notice that I have a cos cubed theta and a plus 3 cos cubed theta. So in total, I have that cos 3 theta equals 4 cos cubed theta by combining those two terms minus 3 cos theta. And this is exactly what we wanted. We have cos 3 theta in terms of just cos theta. We have a cos theta term and a cos theta cubed term. And questions like this are quite common, and they're not too bad as long as you make use of DeMoivre's theorem.
She saw far off the great river.